Yeah, so some of you might know that I spent the last 5 years of my life working at Google at V8, on V8 with the JavaScript engine. Oh, I need the mic. Okay, yeah, on the JavaScript engine, and I also was on this TC39 JavaScript committee for 5 years, and as you can imagine, that's not the least frustrating job on the planet. So I finally moved on, and I want to show you what I'm working on today, and then in the latter half of the talk reveal what that has to do with ML. So yeah, WebAssembly. What the hell is that? So in a nutshell, it's a new binary code format, which is intended to bring like almost native code performance to the web, so to every browser. It's going to be built into every browser. And that is not something we just do at Google. It's actually a joint effort by all the major browser vendors. So we have a so-called community group currently under the W3C roof, and we design that and implement that together. And it's all in the open on GitHub, and you can see all the design docs and everything if you want. I'll give you a link later. And we started a year ago, and we actually intend to ship it this year. So the first version is supposed to ship this year. At least in Firefox and Chrome, Edge and Safari might be a bit later because of their release cycles. So why are we doing this, first of all? Well, various reasons. So the most important one is there are a gazillion languages these days they want to run on the web as well, right? So there are a gazillion compilers that compile to JavaScript. And if you've ever used JavaScript or written a compiler that targets it, you may be aware that it's not like the ideal compilation target at all. So we want to change that and make the web a better place for other languages to compile to and run on. And also that enables us to actually include features that are not a good fit for JavaScript, so threads would be one example. That's the one side, like language support. The other side is performance. So we want to get within 20% ideally of native code, as native code would run on your target platform. Actually, JavaScript is often in that ballpark as well, at least it can be in the best cases, but the problem with JavaScript isn't really peak performance so much, it's actually the predictability of performance. So the big problem with JavaScript is you can easily run, like, by just increasing your data set size by 1, you run into a performance cliff or run off a performance cliff and get 100x slower. That's not rare. So this kind of thing is not supposed to happen in WebAssembly. So you really get the performance you expect. And some of you may be aware of some technologies that already exist in this space, namely ASM.js, this weird subset of JavaScript, and also that what was done by Mozilla, and Chrome or Google had this native client technology, which allows you to run native code on the web. And yeah, one goal is basically to supersede both these technologies. And both the teams that worked on ASM.js and that worked on NACL are now working on WebAssembly. So everybody's on board with the new technology, which I think is pretty cool and pretty surprising that this worked out. So before I'm going to tell you what it is exactly, I'm going to tell you a couple of things what it's not, because there sometimes is a bit of confusion about that. So first of all, it's not a programming language. I mean, technically you can view it as one, and I actually do, but this is meant in the way that you're not supposed to program it manually, right? It's a compilation target. It's a VM, more or less. But it's also not a new VM that we add to browsers. It's actually running in the same runtime, on the same heap, the same compilation infrastructure that already feeds the JavaScript VM. So it's just an extension of the VMs that browsers already have. So it's actually a pretty lean extension to existing browsers. So unlike some other things like Java, if you run Java on the web, you need to install a whole new thing. Also, one thing I want to stress here personally is that the whole design we're making, I mean, the web is the initial motivation, but we're trying to make it not specific to the web. So there already is at least one guy who's already working on a standalone VM for WebAssembly, and my goal would be that you can use it to run your own toy language, for example, in other environments too. Yeah, the name is a bit of a misfit, but it's actually neither web nor assembly, but yeah, I mean, you know, PR and everything. So Yeah, one thing, it's not a walled garden of any kind. It's completely open. But in this space, there are quite a few goals you want to achieve and design constraints. So I want to tell you a few of them. So first of all, this format, unlike other VMs we had before, is really supposed to be language independent. We don't want to bake anything language specific into it, in particular not like any heavyweight object model or anything like that. At the same time, it's also hardware independent. And the slogan here might be actually, it's an abstraction over the hardware. It's not an abstraction over a specific language. So that means that what we have there is basically just factoring out the commonalities of all modern CPUs into some nice format. So that means it's fast to execute once you compile it. You also have to make it safe to execute on the web, and there are a couple of measures we take for that, which I'm not really going into that much, but yeah, we want a deterministic semantics. And one thing I personally care about, of course, is that this is also like semantics that is easy to reason about. So there are a couple of restrictions to the code format that makes it more structured than, for example, the JVM or something like that. So this is kind of on the semantics side, but on the web specifically what's also important is the representation side, like what's your transport format. So there are quite a few constraints there as well. So obviously it has to be compact. You also want to make it easy for compilers to target this format. But more importantly, on the client side, it should be fast to load, right? That's the most important thing in a way. And that includes that it's also streamable, so you can actually start compiling stuff without actually having seen the whole thing. And in a similar vein, it should be parallelizable, so you can actually start to spin off tasks that do certain things before you have seen the whole thing. Okay, so finally get to what it is. Well, it's basically just a VM. It's based on bytecode, unsurprisingly, and it's also unsurprisingly a stack machine. But there are a couple of things that make it a bit different from other stack machines. Oh yeah, and the stack machine, basically the types it operates on are the machine number types, really, right now. What makes it a bit different is that, for example, control flow is structured. So there are no random jumps. You only have the equivalent like of a break out of a block, basically. So you always know in advance what you're targeting and what that type is, what the type of the continuation is. Also, by construction, you can't have any irreducible control flow. And that simplifies quite a few things in the backend side, yeah.
Does that mean you don't have like tail calls? You can write poetry?
So tail calls are not in yet. It's one of the features on the post 1.0 agenda. I get back to that, but yeah.
But what about C?
So, right. So, I mean, C is actually our first client, right? So there is a PLDI paper by Alan Sakai where he explains how you can compile arbitrary go-tos into this kind of structured control flow. He calls it the relooper algorithm. And he invented it for ASM.js because he had no choice there, right? So it actually works. And it's not too bad. Yeah, and one part of the safety thing I mentioned is that the whole thing is actually fully typed. So there's a type system and everything is checked as part of validation. So if you want to view it as a language, this is roughly what it looks like. I'm not going to go through all of that, but the main idea is a WebAssembly binary is what we call a module. A module has a bunch of things in it. I left out a couple here, but the main thing is it has a bunch of functions in it. And functions then just are built from stack machine instructions. So most of these should be kind of like unsurprising, like arithmetic operators. Then there's control flow, yeah, and you have virtual registers called locals and all that stuff. You can do calls. Right. So we have a little S expression format to actually write code manually. So I mainly invented that for writing the test suite. I made that up on the fly, but as has never happened in history before with S expression formats, it's stuck and it's now the official So here you see a recursive factorial function in the stack version. You don't have to read all of that. So actually, this is like the linear stack format, but we have a little bit of syntactic sugar, which allows you to write this equivalently in a more expression-oriented form. So you can just fold a linear sequence of instructions into like prefix form. This then just serializes. This is just easier to read because it groups the expressions in the right way, but it's absolutely equivalent. There's no semantics behind this. So, but there you can probably more easily recognize the factorial, the recursive factorial. You can also write it imperatively, but let's skip that. Let's skip also how you hook that up with JavaScript. So the current status is, the design version 1.0 is almost stable. We had tag previews actually already half a year ago at the Game Developers Conference, where we showed that off with 3 browsers, and there was a binary that all these browsers could already load, which was like a 3D game, Angry Birds, I think. Which you can actually still run from our page if you have one of these browsers and enable the right flags. We have 2 compilers targeting it right now, both more or less LLVM backends, one directly and one going through this mscripten package for ASM.js. What is missing a little bit yet is other tool support, like especially debugging and stuff. So the roadmap here is to really get version 1.0 out of the door as fast as possible, and there's this management speak calling this the minimal viable product, which is just another word for saying the minimal thing that doesn't embarrass us, right? So, and then after that, we just want to ship and iterate, or as this philosophy, or as we call it in the VA team, shiterate. For some reasons. And the goal for version 1.0 is really to be a replacement for ASM.js. So the focus right now is really on targeting, on allowing C to run. But we definitely want to add more interesting features for more high-level languages later. So now I get to the interesting part for this workshop. So we want to have a specification, and we actually want to have a formal specification. That means that validation is expressed in terms of a proper type system with typing rules and everything, and we want to have a small step operational semantics and a soundness proof between these two, and so on and so forth. And I have a sketch on paper of these things, which is actually pretty simple, like the core is just 2 pages. But for now, we don't really have a written spec, but we have an OCaml version of the spec, an interpreter written in OCaml as a proxy to this formal spec. And I wrote most of that, and that's what I want to talk about in the rest of this talk. So the idea is that this interpreter is really as close as possible an OCaml rendering of what you would write on paper in a formalization. So for example, you have a typing judgment which roughly looks like this. So E ranges over instructions, and instructions have this stack type. They take certain stack to another stack. So a stack is just a list of the types of individual values, which are T. And then you have the obvious judgments like binary operators just take 2 things off the stack and push another thing, and a couple of other examples here. I probably don't have time to go through them, like have similar rules. So most of these rules are really simple, actually. And the OCaml rendering of this then looks roughly like this, and you can hopefully see how it like directly renders these rules. So that's the idea. Similarly with the operational semantics, I probably want to skip that, but it's kind of a similar idea. You just have these reduction rules, and they kind of are translated into code. So yeah, what I want to give here is a little experience report of how well that went using OCaml and a reference interpreter. So all the usual advantages of functional programming apply. So it was really fast to develop. I mean, at least initially, it took me 3 days to get something up and running. The code, as you saw, is really fairly concise. Obviously, types help a lot, let alone data types and pattern matching. I mean, obviously. We made some good use of functors because we have number types of different widths, so we could just have a shared implementation of those. And for OCaml specifically, so most of the other things probably apply to most functional languages, but OCaml specifically also has some nice, like low-level data types and functionality that came inconvenient for us because it's a low-level thing. So in particular, big arrays allow us to represent the linear memory and access it as with arbitrary number types, basically, so you can cast in and out of that. Yeah, and it obviously has a very good toolchain and is available on a lot of platforms, which was important for us. So. But, so all this should be obvious to most people in the room, so I keep that part short. There were also a couple of things that we bumped into, obviously. And the biggest one probably was this entire cultural clash that we encountered. Like, you have to keep in mind that most people on this project are compiler hackers with a C++ LLVM background, and that's really their universe. Everything outside that is weird, right? So you had a lot of things, I'm just paraphrasing some quotes here, where it's like a constant struggle. So this one particular is like, we had that so many times, right? And I mean, doing this would of course defeat most of the purpose of doing this as a reference interpreter that is a rendering of a formal spec. Right. So one thing that makes me particularly sad is the perception of module interfaces as header files, and how can you possibly require something like that? And it's hard to convey to people that this is not at all header files and it's actually a feature. Yeah, and then the usual stylistic things about how much type annotations you put in and variable names and things. So this is probably unavoidable. But there were also a couple of things more specific to a camel that might be avoidable, I guess, which point to a bit unfortunate design decisions. So for us at least, that we had to use a lot of these other integer types, it's really painful in OCaml because there's no syntax for them. You have to use module functions. Nominal records are really annoying when you have a complicated syntax tree defined in one module, and a lot of these nodes have similar fields, and then you always have to invent stupid names.
Did you consider using objects?
No. Obviously not. You can't pattern match on them. I mean, that's useless. So.
We support having several records with the same field name.
I know, but you get all sorts of weird warnings, and it's like, you have to put type annotations in various places that's non-obvious. Really, it's like a half solution, but not really a proper solution. One thing that's also like really confusing to newcomers in OCaml, I noticed, is the whole semicolon thing. And the double semicolon thing, and they never know what to put. And whereas if you put a semicolon in the wrong place, then you often get like a syntax error 2 pages later, right? And which brings me to the next point. The syntax error messages in OCaml are of course abysmal. It just says syntax error and gives you no hint what the hell is going on. Related to that, of course, type error messages are much better, but for newcomers, obviously, that's still an issue. And then, yeah, I mean, functors, as much as I love them, obviously they are a barrier to entry for many people. But, yeah. So these are barriers to entry for newcomers, but I think there are also a couple of pitfalls that even experienced programmers like myself can fall into on a regular basis. So I have a couple of those. My biggest one is unspecified evaluation order. Sorry, that's terrible. And yeah, especially when you want to write concise code, then this is often not possible. You have to pull out stuff in lets, and it's all of a sudden 5 times as long. It's really unpleasant. There are these syntax quirks, like my favorite one is this rock, paper, scissors precedence between if and let and semicolon. Like, let wins over semicolon, if wins over let, but semicolon wins over if, and if you refactor code, it suddenly has, like, just delete a line, it suddenly has a completely different meaning if you forgot to put in the right begin ends. And, yeah. So I fall into that trap myself. Equalities is kind of sad that it has a couple, so sometimes you don't know which one to use, especially because none of them has the right semantics. And one more specific thing is an OCaml yak I ran into is like the way you get source positions, you have to get them from the lexer in a stateful fashion. Oh, okay. Sorry?
Veneer.
Yeah, sorry. Didn't try that. So, which all works fine until you actually try to have functions in your semantic actions, and then, yeah, you always have to remember to pull out that and put in Latin stuff. Some Wasm-specific problems, of course, like there's no float 32, there are no unsigned semantics built in. Nans are, at least on some architectures that have x87, are not stable, so they use x87 registers, and you can't actually turn that off. There's no compiler flag that prevents that, even on modern architectures where it should be completely unnecessary. And some other limitations. The ecosystem, yeah, so binaries are not available on all the platforms, or are like for the previous version or a version before that, and in particular in the Windows case, it's like there's not much love for Windows, obviously. And I want to praise Jonathan here for his like packaged up version of OCaml on Windows, which you can run without installing Cygwin, which is a big deal for the Microsoft people on this project, who are not very thrilled about having to install Cygwin. They really wanted to have a one-button solution. So the build system, like, is OCaml built in or out now? Does it run on Windows? No, it doesn't really, and that's another problem. So we actually generate a big batch file to just have a one-button solution for compiling on Windows. I'm gonna skip that, a couple of other things. So overall, I think this thing worked quite well, at least technically. We managed to make it the official requirement for future features of WebAssembly to actually go to the reference interpreter. You have to have a formalization and an implementation in the interpreter to get your feature adopted. But mostly this whole thing is maintained by myself, and sometimes a couple of other people contribute, which is not what it should be. So if there were more people with language or OCaml background on this project, that would definitely help. Yeah, and part of the most of the reason is that you don't only need FP or OCaml experience to do that. You also need experience in like how you write formal semantics, right? So you really have to be in the intersection of both to hack on the interpreter. And I don't know how to avoid that, but that's definitely a problem. So most people just ignore it, unfortunately. So my last slide is what I promised earlier. So this is version 1.0, as I said. It's like mainly to support C, but what I really want to get to is better support for high-level languages, and we already started working on some of that. Hopefully most of that gets in next year, and that's like all the things you want to see for your favorite language, right? Like especially here, I guess, garbage collection support and tailpolls and things like that. And yeah, I want to close with my plea then to you guys to help out, like once this has shipped, please write compilers for this, port your favorite language to this thing, and help us to break the JavaScript monopoly on the way.
Yes. Have you looked at implementations of languages that do different things with the stack than C? For example, Haskell, its stack is very different. It's lazy evaluation scheme, stack is very different. C.
Yeah. So actually, the stack support here isn't quite adequate for C either, because it's a trusted stack, so you can't actually like take addresses on it. So a C compiler actually has to build a shadow stack. Which is, I think, a good thing to require. But yeah, basically, we have looked at them, and it's in the head of our minds that there are requirements and features that other languages might need. So the Go people also talk to us. They want to be able to copy stacks and stuff for their lightweight threads and stuff. But all that is not in the MVP. So there's probably going to be some stuff like that later, but has not been a priority yet.
Have you thought yet about the question of how to do control language control?
Yeah. So actually, this is probably one of the bigger differences with previous VMs. They always try to have this like object model built in, this common object model, and that's also where they failed, basically, right? Like this interop promise never really materializes in practice because there are always these impedance mismatches, even tiny ones that kind of break the whole experience. So we just don't try to do that. This is really an abstraction over the hardware, more or less. And if you want an interop layer, you have to design it yourself. Basically, your compilers have to agree on how they represent things. But it's complete, WebAssembly itself is completely agnostic to that. So you can define it, but you don't have to worry.
Does your MVP have a way of like reaching out to the DOM?
Oh, yeah, I should have mentioned that. So it runs in the same VM as JavaScript, and basically you can just call into JavaScript functions. So JavaScript is your FFI here, so that's how you access the DOM. You can just import a JavaScript function and call it.
So unfortunately, time is over. Please discuss.